Good morning everybody, and once again welcome to the video. This video I'll be essentially talking about one of the articles that I have published on LinkedIn. The title of the article is Serverless Data Enrichment Pipeline Using Step Function for Sourcer Product 1000 requests per second. This is the entire architecture, and essentially usually when we read stuff, right, some people understand much better on a video, which is why I decided to essentially make a video content of my article. Okay. So this project I did in my firm, right? These are the authors, right? Myself, Birendra Singh, we have Divyansh Patel, right? And a special thanks to our Chief Technology Officer for granting us permission to share project insights with others. So what is this project about, right? So we have data essentially in Elasticsearch, right? And we have a product built on that, which is called Sourcer, which essentially allows recruiter to reach out to job seeker from a one unified platform. Now, what we wanted to do is, as soon as a recruiter reaches out to a job seeker, we wanted to essentially enrich the data for the job seeker. Now, there were following requirements. So for example, the system needed to be highly available and strong error handling had to be required. They wanted to view crucial data like how many candidates have been updated or how many enrichment failed, and the dashboard needs to refresh instantly, providing a real-time updates on the state of enrichment. So all that stuff they needed, right? So now comes the tech stack. I'm a big fan of AWS, right? I try almost to use all the services as possible, right? So for this I use S3 as my data lake, right, where all the enriched profile and failed items will land on the data lake, where we run glue crawlers and Athena, and we can query this data via standard SQL, right? Again, glue and Athena, I just explained that. Lambda, the entire project is based on Lambda, so we use step function that helps essentially to orchestrate lambdas, right? We use SQS since we opt in for an async model, which I'll talk as we progress down. Okay. Then step function, SNS, OpenSearch, ECS, and Route 53. All right, this is the architecture. We'll go one by one particular block at a time. So the first particular block that I have is this one. So the APIs are built on Flask, right? Flask is the framework that we use to essentially build microservices. We Dockerize the app, and the app is hosted on an ECS container, essentially. And then we have essentially load balancing is set up on that, and we have exposed that particular endpoint via a Route 53. Now this entire API is under a VPN, right? It is not a public facing, so it's under a VPN. Now the user will interact with the API with a Swagger interface, or using any of the programming languages they are using. We provide them code snippets, right? So they provide as soon as they say, hey, I want to enrich this particular information, right? We put that particular information on an SQS. Now you will ask me, hey, why SQS? Because we want to do an async model. So as soon as the item lands on an SQS, we return them a token saying that your request has been acknowledged, which means I got your request. Now I'm gonna work on that. So now as soon as items are there in the SQS, if you observe this particular block, there is an internal polling lambda that's gonna poll the queue at a leisurely pace. In this case, we are using long polling, 20 seconds. So that's gonna poll the queue, and if there are any messages, it's gonna pass it on to a lambda. Lambda is gonna verify the payload, right? And once it does verify, it will add certain metadata to it. And once it does add the metadata, it's gonna put the payload or essentially pass the payload to a step function. Step function is where all the heavy lifting work is done. So here you can see, right, first, we essentially call the credits API, and then using in the step function, we do check the state of the credits. So we check either it's a success or it's a fail. Or if something fails, we try 3 times. Basically, in step function, we can easily define error handling and what we want to do on those scenarios, right? So we try for 3 times, and even if that fails, we publish to an SNS endpoint. And now all the people who are subscribed will get a notification that APIs have failed, all right, with the particular payload. Assuming the APIs are fine, it's gonna go inside the API state, it's gonna check the threshold. So we wanted to implement a feature because see, when you're working with credits, you are often gonna hit a threshold or a low. You want to essentially remind customers that, hey, you are running low on credits, you might wanna buy one, right? So we essentially check whether you are at threshold. If you are at threshold, we publish to the SNS again, a new topic, and then move to the business logic, right? So all that happens. And here all the enrichment happens, right? Now, here are the list of all the SNS topic we built. For example, I'll go one by one. Connection, right? So this essentially maintains a connection between a job seeker and a recruiter and essentially the enriched data, right? Then we have an SNS topic for credits alert, right? So this is when an event will be published to this topic whenever you're running low on credits or threshold, right? API fail state, whenever an API fail, we'll publish to this, and anyone who is subscribed will receive those events. This one is pretty amazing. Daily report alert. So what this does is we have a Lambda that runs every day at night on a cron using Event Bridge, right? Now what we do is essentially this Lambda will crawl over the data lake and it's gonna gather the metadata information. For example, okay, how many records failed? How many records succeeded? And then it's gonna compile a nice report and it's gonna send a report to all the subscribed user. Threshold, I already explained you that. This is enriched resume, which means anytime the resume is enriched, what we do is we publish an event to this SNS topic. Now we have 2 subscribers. In future there might be 400, 500, we don't know. There might be multiple subscribers. One of the subscribers will put the data into the data lake. Another subscriber is gonna essentially put the data to the Elasticsearch for search purposes, okay? Again, we have all the data on S3. We use Glue, Athena, and then, if needed, the user can build dashboard using QuickSight. Alternatively, we also provide creating dashboard using Kibana, right? These are all the explanation of all the SNS topic, and this is how the dashboard looks like on Kibana. So we provide a very easy interface for our product managers. They essentially can input, a recruiter ID or a user ID from the dropdown, and they can essentially filter down the dashboard. On the top right corner, there is a filter which helps the user to filter down items based on a date range. Okay, so here you can see 12 enrich were completed, 8 failed, 1 was not queued. You see a beautiful chart which recruiter essentially contacted with job seeker, how many, what is the count for that, right? Here is an amazing real-time graph that essentially shows you the status of the enrichment. For example, is it pending, success, failed? So it also shows you the timestamp. So if you hover your mouse over those triangles, it will show you the status of those items, right? And Kibana has a beautiful feature where you can filter down to particular time date range, right? I can go like, hey, show me in last 1 year, show me in last 3 years, etc., etc. Again, now we have also data tables here. For example, now you can see if a particular payload was failed, you will see the timestamp when it failed, who was the recruiter, what was the profile ID, what is the status, and what is the message. So in case of fail, we also want to upload the raw error message, right? So for example, here you can see there's a timeout error. On the left hand side of this dashboard over here, you see all the crucial information. For example, recruiter ID, person's email address, right? A person first name, last name, LinkedIn URL, profile ID, etc., etc. So all those details are seen here, right? Again, JMeter testing, right? It's a very robust solution because the reason this is robust is because we are using an async model here, right? We are not waiting for the system to complete and then, so the user doesn't have to wait for the system to complete. The user simply puts the data or simply makes a request. That request is essentially put into an SQS queue and an acknowledgement token is returned to the user. Now the background workers, in this case lambdas and step functions, are gonna do their job, and once it's done, they are just gonna publish on a required topic. And people who care about that data can subscribe to one or many SNS topic. I hope you have enjoyed this particular article, and if you have any more questions, please list your questions in this article, or you can simply comment as well here. I've already listed that. and we'll try to answer all the technical and non-technical questions that you have. Once again, thank you so much for watching, and I wanted to extend a thank you note to our CTO who gave us permission to share all this insight with the community. Again, you have a high-level architecture diagram. This should give you a pretty good idea of how the system is working and what all components are involved in this project. Once again, if you have questions, please kindly comment on the video or comment on the article. And once we have time, we'll try our best to answer all technical and non-technical questions. Thank you so much for watching. I'll see you guys in the next video.